All right, so I ended that little one a little bit sooner than I meant to, but that's okay. This will give me a little more time to get through these ones. So I want to move on to number 6, and then I want to do a couple of the word problems. So let's start with number 6. So number 6 says, find the missing values of a geometric sequence. They're giving me that u sub 1 equals 4, r equals 3, and s of 10 equals blank. Obviously, that's being our missing. So from here, we know that the first term is 4, we know r is 3, and then this thing right here is our n value, n equals 10, right? Because the normal function the equation that we're going to use here is s of n equals u sub 1, because it's geometric. So u sub 1, 1 minus r to the n power, all over 1 minus r. So let's just substitute values in. S of 10 equals u sub 1, which is 4 in this case, times 1 minus my ratio of 3 to the power of 10, all over 1 minus my ratio of 3. So now I'm going to take my calculator out, and I'm going to do 3 to the power of 10 first. I'm going to do 1 minus that number. So right now I'm at negative 59,048. Multiply that by 4, and then divide that by negative 3 when I do, or sorry, negative 2 when I do the 1 minus 2. And I get 118,096. So we get a pretty big answer. But it kind of makes sense because I'm starting with 4 and I'm going to be multiplying things by 3, so it should be pretty large. And that is the answer for number 6. All right, moving on, we'll do number 8, the first word problem. So this one's a little bit tricky because you got to pick out the important things. So the first time you run a 5-mile distance course, it takes you 49 minutes. You run the same course 1 minute and 30 seconds faster each week. How fast can you run the course over 15 weeks? The thing that you want to look at is the very last question, which in this example is how fast can you run the course after 15 weeks? So what they want to know is what's the time at the 15th week? So we're talking about time. So we're going to look at stuff that involves time. So we're going to read it again and look for things that involve time. The first time you run a 5-mile distance course, that doesn't have anything to do with time, so that's not relevant to me. It takes you 49 minutes. Well, there you go. My first thing is 49 minutes. That's how long it takes me to do it the first week, right? Week 1. You run the same course 1 minute and 30 seconds faster each week. Well, there we go. It's another thing of time, right? So in this 49 minutes, I run faster next week by 1.5 minutes. So I'm going to subtract 1.5 minutes from that to get 47.5. And that's week 2. Right? And I'll continue to do this. This is going to be arithmetic because I'm subtracting 1.5 minutes each time. And they want to know how fast can I run the course after 15 weeks. Well, they don't ask me how fast I run the course over the total time I'm running or how much time I spend running. They just want to know what is the 15th week's time. So I'm just going to do the explicit formula for an arithmetic series. U sub n equals u sub 1 plus d n minus 1. I obviously know u sub 1 is 49. I know my difference in this case is 1.5 negative because I'm subtracting each week, and then I can just go from there. So I know I'm looking for the 15th week, so u sub 15 equals the first term, which in this case is the time for the first week of 49, minus the 1.5 minutes each week times n minus 1, except n here, pardon me, is 15. So I know that. Well, let's do some calculations. Remember to make sure that you don't add these things up, okay? That's a big sort of no-no. Don't do that. You can't add up the 49 and negative 1.5 and then multiply it. I've seen people do that recently. Please don't do that. So negative 1.5 times 14, and then add that to our 49. And this guy's doing a pretty good 5 miles with 28 minutes. Not bad. What is that, like? That's actually incredible. This person's running 5 miles in less than sub 6 minute miles. So good for this guy. Or you, I guess, since you're doing it. All right. The way I could adjust that to use the formula is I could say how much time did he spend running over the total 15 weeks. That would use the S of n equals blah, blah, blah for the arithmetic, because we're talking about the total amount of time he spent running over those 15 weeks. But the one that we just did, it doesn't have that. So it's literally just asking what is the time of the 15th week. You're just using the arithmetic formula. All right, let's go on to, let's do number 9. Number 9, a 6-year lease states that the annual rent for a retail space is $92,000 the first year and will increase by 4% each additional year of the lease. What will the total rent expense be for the 6-year lease? So there you go, right? What will the total rent expense be? So we're looking for things that involve expense. The first year is $92,000, right? 6-year lease states the annual rent for a retail space is $92,000 the first year, and it's going to increase by 4% each additional year. So our first year here is $92,000. So this is number 9. $92,000 for the first year, comma, and then I need to find out what the other terms are if I want to do this for 6 years, but I actually don't even need to do that much work. My ratio here is going to be 100% plus the increase, because we're increasing by 4% each year, which would be 0.04. So that's kind of like from chapter 4 or like 2 when we were talking about increasing, decreasing. But that's my ratio. So it's going to be 1.04. And if I want to find out the total sum of the 6 years, then this is a partial sum of a geometric, because I have a common ratio and I have a starting value. So we know that this is going to be u sub 1 minus r to the n, all over 1 minus r, and we'll change this 6 to an n as well. Okay, and we're going to fill values in. This is my u sub 1. This is my ratio 1.4, and that's as much information as I need, and then I know that n is 6. Throw that in there. So S of 6 equals 92,000 times 1 minus 1.04 to the 6th power, all over 1 minus 1.04. So the sum of 6. And then this is, again, straight up calculator. At this point, if you have this part, you've already earned like 2.5 points out of 3 on a test, but being able to execute in the calculator is obviously worth points. So 1.04 to the power of 6, 1 minus my answer, times 92,000, divided by 1 minus 1.04. And I get 610,000, pardon me. 610,233 point, and we're going to go $74. And that seems reasonable, right? We're doing 6 years. It's about $100,000 a year, if not a little more. So it makes sense that we're about 610,000. And that's a really, really expensive. What are you leasing? Oh, retail space. Okay, that makes sense. That's not an apartment. Okay, we'll do one more, and we'll leave it at that. Let's see. Let's go ahead and do number 11. Each year, a certain type of tree grows vertically 80% as much as it did the year before. If the tree grows 1.3 meters in the first year, how tall will it eventually grow? Ooh, how tall will it eventually grow? Okay. Well, it grows 80% as much as it did the year before, and they're asking me how tall it's going to grow eventually. Well, eventually sounds sort of like, infinitely to me, like it's just going to keep going. So this is an infinite geometric series. I know that the first term is 1.3 because that's how much it grew to start. And I know that the ratio is 80% as much. So this is one, well, I guess actually they worded it really well. We can just say it's 0.8, right? You're getting 0.8 of the amount that you gave in. So 0.8 is my ratio. And we're going to use our S equals U sub 1 over 1 minus R. So it's also important to note that I can use this formula because my ratio is less than 1. I think if you look at the practice or the in-class review that we did, number 3C. Sorry, this is a side note. Number 3C on the in-class review was this. A lot of people got some crazy number. Okay, this is in fact a geometric series, but this is my ratio. My ratio is 4. And since 4 is greater than 1, I mean, think about it, right? My first term here is going to be 1. The next number would be 4. I'm multiplying by 4 each time. So I'm going to get these huge numbers. All right? So if I keep adding those up, it's going to go to infinity. It is going to diverge or approach infinity. So there shouldn't be a value for this. A lot of people got like negative 1/3 or something, and that's, you got to be careful about that. You have to check, is your ratio bigger than 1? And if it is, you can't use it. My ratio here is less than 1, so I can use this formula. I put in 1.3. I do 1 minus 0.8, which gives me 1.3 over 0.2, and I use my calculator because I'm not a human calculator. Let's see, divided by 0.2. 6.5. So that seems reasonable, right? It's going to grow 6.5 meters over the course of its life, and that's it. So the big thing with word problems is definitely look at the end of the problem, look at the question, what is it asking, right? Number 10 asks you how many cartons are there, so I want to know probably the entire summation of all of them, or what will the total expense be? That's, again, the total summation, or how fast can you run after blank, right? That's a single thing. How tall will it eventually grow? So that tips you off to which numbers are going to sort of relate to what. Because you want to find out what's your first number in your sequence. But in all of these, I'm basically trying to generate a list, right? Or figure out what kind of a list it would be in terms of like, is it going to be arithmetic or geometric? And then be able to use like the appropriate equation based on the fact that it's geometric, or, you know, based on the fact that it's, I think one of them is arithmetic, right? Maybe not. Based on the fact that it's infinitely geometric, like this one. I think number 10 was the one that's arithmetic. So just be careful as you're reading through. There's not going to be a ton of those on the test, but, you know, I guess it's important to be able to distinguish what's going on in those problems, but don't focus on them too much. And I don't know why I'm scrolling up and down. I guess I'm bored. So I'll post both of these tonight, and the answer key for other stuff is up as well with the work shown, so definitely check that out. And good luck on your studying. I'll see you guys tomorrow.